back to Conversations with Agents of Change, the podcast where we explore the inner journeys and outer impact of people shaping a more sustainable, compassionate, and resilient future. I'm your host, Izzy Boyd. Today's conversation takes us into a space that quietly underpins almost everything around us. Our homes, our roads, our cities, our infrastructure, the materials we build the world with. Because when we talk about climate change, sustainability, and the future of our planet, we often think about energy, transport, or food systems. But one of the biggest and least visible contributors to global emission is construction. And at the heart of that lies cement. My guest today is someone working directly at that intersection of science, industry, and transformation. Allistair Wilkinson is a sustainable materials expert at CDE Group, with over a decade of experience spanning academic research and hands-on operational roles in the cement industry. He specializes in cement decarbonisation, calcined clay-based supplementary cementitious material, and circular economy solutions, bridging the gap between theory and real-world impact. But what makes Allistair an agent of change isn't just his technical expertise, it's his commitment to asking better questions, to challenging long-standing industrial norms, and to proving that innovation and responsibility don't have to be at odds. Allistair believes that the future of construction can be lower carbon, circular, and smarter, and the transition must be practical, scalable, and grounded in reality. So today we'll explore how someone becomes passionate about sustainable materials, why cement matters more than most people realize, what decarbonization actually looks like on the ground, and how science can become a force for systemic change. Allistair, welcome to Conversations with Agents of Change. It's great to have you here.
Excellent. Thank you very much. Great to be here.
Allistair, I'd love to start at the beginning. Most people don't grow up dreaming of working in cement or construction materials, and yet here you are, deeply committed to transforming the sector. What first sparked your interest in materials and sustainability?
I grew up around the construction industry. So my grandfather was a bricklayer. My father, he was a building surveyor in the local council and building control. So I always grew up around the kind of the built environment and structures and that type of thing. But going into material was never the dream. It's never something I aimed to do. My main interest actually was always in business and in business study. So I kind of thought, I enjoy building, I enjoy the built environment, I enjoy learning about buildings and that type of thing, but I enjoy the business side of things, so I thought the natural thing for me would have been to be an estate agent.
Okay.
But I decided that I wanted to have fun more than focus on my A-levels, so it didn't get me results, and I ended up getting into a course at Ulster University. I was building engineering and materials, and really that's where it started. It was a real kind of stumble in the dark. Got into the course, it was the closest aligned to what I'd wanted to do, is in this right type of area. And really as it developed through, that's where it built up. I was focused on construction, obviously, but there's a heavy lean towards materials and obviously concrete. And really as we went through that, towards my final year, one of my lecturers said, I've got a PhD topic, would you like to do it? I don't think, I'm not that type of person. It was get me a degree, go and get a job. The idea of a PhD and research never really come into it. So thought about it a while, and it was in low carbon alternatives to conventional cement. And I thought, you know what, it's 3 years, it's an extra qualification, it's as good as a job, and the experience alone, it'll be fantastic. So that's really where it all started. So very much I stumbled into the cement industry, word of mouth. My supervisor knew somebody who worked in the cement plant. They were looking for a new lab technician. I was coming towards the end, and it was a case of, well, Allistair's from Cookstown. He lives 3 miles away from the plant. He's got a PhD in cement. Why not?
There you go, yeah.
And that's how that then happened, very much by accident. And it's just something, as my career's moved on, I've really just developed into and started to get a better understanding of sustainability. And really where I'm more passionate about it, having sustainability is more than a tick box exercise for investors.
Yeah.
It's how do we do things smarter, how do we do things better? And really, if you get sustainability right, the underpinning of that whole thing is that the business becomes more sustainable, more profitable, more viable. So that's what's driven me forward and what I've been doing.
I think that academic background really help you think in a different way about the real world problems and to help you to have the tools to maybe extrapolate those things. And also the fact that when sustainability became central rather than peripheral had to do as well with that academic background, or how do you feel about it?
So for me, the transition from academic to industrial, it's not always black and white, it's not split down the middle, but by and large, what I've seen from academics, where there was always looking for solutions for problems. On the flip side of it, my view of industry, and I can see it changing, but certainly the cement industry is a very traditional industry. When I started about 8 years ago, it was a lot of people were looking for problems with the solutions. We've always done it this way. That's a solution, but this will be a problem, this will be a problem. So I always set out to try where I could to bridge a gap and identify the genuine problems that need solved in the industry. And yes, carbon is the easy go-to, but unless you break it down into smaller chunks, you're never going to solve the problem. And I was trying to figure out, well, this is what's possible on a cement plant with a bit of creative thinking. Academically, people are working in this arena. How do we translate it from an academic study to something that we can physically do on site?
Yeah.
And that's really what it has driven me as I went through my career.
That's amazing. And for listeners who might not be familiar with this space, cement is responsible for a significant portion of global CO2 emissions, yet it is essential to modern life. From your perspective, what makes cement such a critical and difficult area to decarbonize?
For me, it's got a fantastic balance of its performance. It can be manipulated to do so many things, to serve so many purposes. Its durability in construction is virtually unmatched. But alongside all that, it's so locally available, it's so accessible. Yes, it's an intense production process, but it's such an abundant material that anywhere in the world you can get your hands on cement. And for that reason, because there's so much of it available, it's so cost effective. That's why it's such an important material. If you build a house with timber frame, yes, you're going to save a lot of carbon, but is it as resilient? Is it as durable down the line? Like, you look around, you look at the pyramids, it wasn't concrete and cement that we know today, but it was of a similar type. And that's been there for thousands of years. And you look at the natural disasters, which is almost ironic, but there's a case to say the cement industry is contributing to an increased number of these disasters. But you look at the California wildfires and you've seen the drone footage of neighborhoods destroyed, and the only things left standing were the concrete structures.
Yeah.
So it's such a phenomenally durable product for a relatively cheap price point. But then obviously it comes with a trade-off, and that trade-off is its environmental impact and CO2.
So then why can't we simply switch it out like other materials?
So there's an increasing amount of research, and even in industry now, there's more direct replacements for cement available. The biggest problem that we have with cement, there's nothing off the shelf really on a great scale that's available globally to replace it in the morning. The research has went into these novel cements. It looks fantastic. There's some amazing products in the market, but it's all so niche, and even long-term durability, nobody's certain of it yet, because it hasn't been in situ for 10 years, 20 years, 30 years, where we know that conventional Portland cement and concrete structures, they've been there for decades, hundreds of years. The other problem that I have with cement in the production methods, the misconception in the public is that we burn a lot of coal and that creates a lot of CO2 emissions, and why don't the cement plants just switch out coal? It's a strong argument, but what people maybe don't realise, no reason to ever give it thought, is that about 2/3 of your CO2 emissions from cement manufacturing actually come from the limestone that's used to make clinker, with the remaining third coming from the fuel. So essentially clinker is the precursor that's ground to make cement, and to make clinker you need calcium, silica, iron and alumina. The best source of those materials is limestone, which is calcium carbonate. We heat calcium carbonate up to get calcium oxide, and it drives off CO2. So it's inherent in the process. You can't replace chemistry. So like for like, there's nothing in the world that's abundant enough to replace calcium carbonate. So it's a matter of chemistry rather than even a desire. And yes, there's loads of things, I'm sure we'll get into it a bit more, but there's loads of things to be done to reduce the amount of limestone used. But it's such an inherent problem with the process that it's now looking for ways around it and ways to contain it rather than a like-for-like replacement.
And I think that's very, very important, what you mentioned there, because that would be the first big misunderstanding that people would have about cement and the sustainability and why it's not as easily to replace. So one thing that it really stands out about your work is how you bridge academic research and operational reality. You were saying before, you've worked in R&D and quality management and product development and sustainability, not just from the theory part, but from the ground. Why is that bridge so important when we talk about climate solutions?
For me, industry is the vehicle. That's the people on the ground that's going to change things. The academic solutions and the research that's going on in universities, quite often, that's maybe the spark that the industry need. There's people that are dedicating their lives to researching this in institutions or whatever, and they've got no means of doing it themselves.
Yeah.
So really, academia and industry have to work hand in hand really to help solve the climate crisis. Like, it's not to say you look at the cement industry and it's pretty much all taken up by multinationals, PLCs, all of whom have their own R&D centres. So it's not just academics and universities doing this work, but it's still very much academics are coming up with ideas and industry has to be able to figure out a way of bringing those ideas to reality, essentially, because there's so much that can be done. And I guess one of the big shifts that I've noticed, even in 8 years, like 8 years is no time really, there's such a change in the mindset of the cement industry in that period of time towards carbon reduction. It went from being a little bit of a pain in the backside that, oh, we're going to have to start paying for carbon emissions through the ETS system. Now it's one of the first questions asked, does that reduce carbon? And so many plants, so many companies won't invest in significant piece of new equipment unless it's a massive carbon reduction impact. So it's now fully integrated into the industry, but that wouldn't have been possible either without the kind of academic background to it as well.
Which is amazing, because that just shows that they need somehow one and the other. Industry alone wouldn't be able to achieve what, as you just said, that understanding of the environment, whereas the academics wouldn't understand as well what are the physical implications or the practical implications, the economic implications as much without the industry itself. So it shows how well interconnected those are. What do you think it happens when innovation stays in the lab and never reaches industry?
It goes nowhere. Yes, you can get academics can get journal papers, they can get publications, all the important things for their day job. But realistically, if it stays in the lab, it's never going to go to scale. It's never going to have the impact that solution or that innovation could potentially have. So industry needs academia as much as academia needs industry.
Yeah, I completely agree. A major focus of your work has been cement decarbonization and the development of calcined, clay-based supplementary cementitious materials. Can you explain in accessible terms what makes these materials such a promising solution?
So one of the things I've kind of already discussed is that with clinker production, that's the vital element of cement. It requires a lot of limestone, which then when it's burnt, it releases carbon dioxide through kind of thermal degradation. The benefit with calcined clay is it needs lower temperature to be calcined. So conventional clinker, it is calcined at 1450 degrees, where calcined clay can be produced anywhere between kind of 750 and 900 degrees. So it's not quite half the temperature, but the fuel consumption is much less than half. So that's the first big win.
Yeah.
The second big win is that the clay have very, very small quantities of calcium carbonate. So what the cement industry regard as process emissions through that process, it doesn't exist with calcined clay because you're reliant on aluminas and silicas that just don't degrade in the same way as calcium carbonate. So that's the single biggest shift. The difference between calcined clay and clinker is that if you grind clinker into a powder in the cement and you mix it with water, it'll react, it'll set. Calcined clay doesn't behave like that. It's what's known as a pozzolanic material. So it has to be with something to trigger it, which is why it's such a good SCM. It can be added as a percentage replacement. So the work that we had carried out, we could replace up to 50% clinker without sacrificing performance. We were able to get then it was approximately 40% carbon production for like product. So you still need some cement there. It's still such a vital component. But what we demonstrated was that actually you don't need quite as much as you used to need. So
That's a very important reduction, yeah. So why are SCM so important for reducing emissions?
The benefit in SCM, it's a direct clinker replacement. So with clinker being the main embodied carbon source material in cement, anything that be done to replace that will reduce the carbon footprint of that cement product. The usual SCMs that the industry would look at is limestone as more of a filler, quite unreactive, but we don't have to heat treat it. It's such a low energy process that the carbon footprint is sub 100 kilos of CO2 per tonne, compared with cement. It could be anywhere up to 850, 900. Ground granulated blast furnace slag, so GGBS, that's the waste material from steel manufacturing. So it's an excellent SCM because it's super reactive, high calcium content, and you can get really high cement replacement levels, potentially up to 80%. It takes longer to set and longer to harden, but the end performance is very similar. And you have fly ash, and that's essentially the material that's captured from the coal-fired power stations. The problem with these SCMs is that steel manufacturing is shifting away from blast furnaces and going to electric arc furnaces. So that material is not as reactive. Likewise, fly ash is coming from coal-fired power plants. There's no longer any coal-fired power plants in the UK, and they're dwindling across the world as we go to more renewables. So industries, in the case of electricity generation, they are really decarbonising. The materials that the cement industry has traditionally relied on to decarbonise will cease to exist. So that's why as well, research into new SCMs is such an important space to be in, but it is a critical part of the whole decarbonisation piece for the cement industry.
That makes so much sense, and it's so interesting that you explain that so clearly. And I think that it's very exciting to see where the industry would lead. What excites you most about it?
There's so many opportunities for SCMs out there. I think part of the problem is that we've got cement standards, we've got concrete standards, and they're all so prescriptive that everybody understands the importance of these standards, because we're building huge buildings, we're building high-rise buildings, and it's a matter of life and death. If these buildings fail, it feels like an exaggeration, but we know, we've seen, if construction materials go wrong, the likes of Grenfell, when it goes wrong, it really catastrophically goes wrong. So I can understand the de-risking side of it. Equally, there's so many tests out there that we can accelerate durability testing, and even starting to get SCMs into low risk construction, start to build up the real world data about durability is going to be so important. There's so many opportunities out there for SCMs. Calcined clay naturally is the one that really excites me. I think it's so accessible. There'll be areas of the world that can't make cement, but clay is in abundance. And one of the big areas, is no surprise that it's Africa. That a lot of the research, a lot of the actual industrial application for calcined clay is in Africa, because very little limestone to make cement, heavily reliant as a continent on imports, and very small geographical locations within the continent to produce. But so many parts of Africa have clay that's perfect for calcined clay. So suddenly you can be in a position where the imports are massively decreased, and you now have countries that can build an economy around one single material that, thanks to research, has really started to come to the fore. So that's a really exciting one. There's other more novel pieces, the likes of graphene, and how it can be added to cement to improve the strength properties, the flexural strength properties, and that type of thing. It's incredibly interesting. Still quite university level, but a lot of really good stuff going on there. And even there's so many waste materials out there, we don't want to just throw anything into cement. But even if we take kind of my new day job with CDE, there's hundreds, thousands of wash plants across the world for washing sand and gravel. And there's millions of tons of material being washed off sand and gravel and being left in piles and in lagoons and landfill sites. And it's about being smarter with how we use those materials rather than focusing on maybe 50% replacement. There's a really strong argument to say, well, actually, we have to do minimal processing to this, but we can replace 10% of cement straight off. Even that, as a global industry, can have a huge impact on global CO2 emissions.
Absolutely, that sounds very exciting. On this podcast, we talk a lot about agents of change and that they don't always look like activists or public figures. Sometimes there are people working inside complex systems, quietly reshaping them from within. Alistair, you are asking, how can we build differently? How can we use fewer virgin resources? How can we close loops instead of extracting endlessly? And that is powerful. At CDE Group, your work focuses on advancing sustainable materials, technologies, and enabling the circular use of resources. What does circularity actually look like in practice within construction and material processing?
So, two very, very big separate topics, actually. So if we start off even with material processing, we know that cement needs sand and gravel to make concrete. So cement's actually, in terms of tonnages and cubic meters across the world, cement is a much smaller percentage than sand and gravel. But we also know that natural reserves of suitable sand and gravel and stone and aggregate is dwindling pretty much the world over. So it's becoming more and more important to maximize the value of the material that you're extracting from the ground. You can make more from less in a lot of ways if you're smart about how you use that material. So for me, the big opportunity is the kind of the sludge, the landfill material. So how can that be integrated, whether it's into concrete, whether it's into something totally unrelated? There's so many opportunities there because the built environment as a concept, it's such a big arena. So there's lots of things that could potentially be done there. It would be naive to think we can find a solution for absolutely everything. There's always going to be waste from that process. Where CDE have kind of almost redefined that kind of industry. Materials that would have been traditionally looked at as being too dirty, have very clay-bound materials. The technology is now there to remove that clay and to produce really high quality sand gravel. So already over the last 20, 30 years, that's something that the company believes really strongly in and is shown on the ground, that kind of natural materials can be processed in a smarter fashion. That then extends to recycled materials. So whether it's crushed concrete, that's the other beauty of concrete. When it's finished its first usable service life, it can be crushed down, it can be separated. You can pull the cement paste out of it, reheat it, then rehydrate it, and it'll behave as an SCM. You can then strip out the aggregates that were already using the concrete and reuse them.
Oh.
So there's so many things. Just because concrete is one structure at the end of its life, it doesn't mean that all it can't be used in something new, which is a bit of a shift in the industry. Like even in the last couple of weeks, there's a new standard come out in the UK to allow for cement paste that's been recovered from crushed concrete to be reintroduced as an SCM. So one of the other things about, I guess, the cement and concrete industry in the UK is everybody feels if we're maybe not doing enough or we're not pushing boundaries. I'd say the UK is actually one of the most advanced areas in the world, and that's all research driven. So being able to reuse old materials is equally as important in being sensible about how we use natural raw materials.
Actually, want to talk that part because I think that part of sustainability is not just about reducing from certain areas, but also to reallocating the use of other materials that are already there. So if they are being seen as wasteful, we can reduce them. And that research has been showing that we can reuse that, which is great news.
And it's not just in the cement industry. I guess another misconception about the cement industry is the idea that it's the big bad, the new tobacco industry. We're emitting millions of tons of CO2 into the atmosphere every year and really quite pleased about it. That couldn't be further from the case. I would go as far as saying the cement industry is probably one of the earliest examples of a proper circular industry. Because most cement plants that I've come across have next to no waste. It's all reintroduced in some fashion into the process. It's a small piece, but it's something that's actually been ingrained into the industry for maybe 20, 30 years now. You then look at the alternative raw material side of things and trying to replace bits of limestone with already decarbonated materials, with other waste materials that maybe don't have a home elsewhere. There's so many opportunities that the cement industry's kind of taking advantage of. And then the big ones, obviously, alternative fuels, replacing what was traditionally very heavy in coal, oil and gas, where now most plants are going to be operating probably in excess of 50% coal replacement, which is amazing. I remember a couple of years ago having a conversation with a guy who was from a cement management background. He managed a cement plant in England and went on to work for a company that produced alternative fuels. So a lot of alternative fuels are kind of blue bin waste. Blue bin waste that has been contaminated in such a way that it can't be recycled. So most companies look at that, shred it up, dry it out, and burn it as it is. It's still viewed as a waste rather than a resource. But what this company were doing was processing the waste in such a way where they were manufacturing a product and didn't mention it as fuel, really changing the mindset of how that was looked at. And one of the biggest things this guy told me was, you go in the cement plant, the operator is used to burning coal, and that's his main fuel. And the SRF, the secondary recovered fuel, is the alternative fuel. He made it his life's mission to get the operators to think of it the other way around, that the recovered fuel, the waste, was the main fuel, and the coal is the alternative fuel. And it's things like that that's happening in the industry that nobody will see from the outside, but it has such a big impact on global emissions. If that was replicated across every plant in the world, and it is something that's starting to happen, it would be an amazing impact on the industry.
And it reiterates how an agent of change you are, because you are, first of all, like speaking out and telling about this and pointing out these topics that otherwise most of us listeners wouldn't be able to. So I think it's very relevant. I would like to ask you another question. What roles does technology play in making circularity viable at scale?
Technology, from high technology to low technology, it's going to be such a critical part of things. It will start off with, I don't even like calling it low technology, but it's more akin to what we know, the likes of the CDE plants, the physical underground mechanical pieces of kit that are processing waste materials or washing dirty natural aggregates to make sure you can maximize the value of every source you have. But AI is such a big thing now, and machine learning, it all plays a role where we can learn to do things smarter. So even sticking with the cement industry, learning what impacts your cement strengths. It's easy in the cement industry. If you start to decrease in strength a little, the first thing you do is the SCMs drop. But it might only be a temporary blip that happened in 1 hour period, and your sample just happened to be at that time. But you then have to wait for 7 days strengths to come through, 28 days. You can lose months just by one little blip that was nothing. Where AI and machine learning comes in is analysing constantly, learning of what to look for, and saying, okay, for this period, because of this inline analysis, we can reduce the limestone addition by 2% to keep everything right. But the following hour, everything looks good again, let's get the limestone back on. So technology is going to be really important for that type of thing.
I'm trying to understand that kind of logic. What was first? Was it the analysis of it, and then the technology went back to support that, or vice versa? Or was it that the evolution of the technology that led you to get to those results?
My research was in calcined clay originally, from a different perspective, but it was something I was always been aware of when I started in the cement industry. It started with analysing a material that certainly it wasn't the main material for a cement plant. Clay generally is viewed as being as a bad thing. You don't want it in concrete in its raw form. That's why people spend money in wash plants to wash it off, sand and gravel. We've seen awful things happen in Donegal locally, where excess clay and mica and different things in concrete blocks, that's swelling over time, and houses are literally collapsing. So clay is viewed as a negative, but if you know what to look for in terms of the analysis, you can start to identify, well, actually that clay could be calcined to become a really good material. And I guess where we were different, the industry kind of approach is, there's novel technology out there for making calcined clay. We thought, well, why don't we try this through our existing infrastructure, through our existing kiln? But the more efficient way of doing it is probably a new build. So there's new technologies in how to calcine clay and how to make clinker. Electrification seems to be a big thing that's coming to the fore again, and even away from calcination, mechanical activation. So like really high intensity ball milling or grinding has been demonstrated to do a similar change in chemical structure of the material to what burning does.
Wow.
So it's a novel, I say novel, it's out there, it's commercially available, it's being built in Europe, and there's a number of plants are on order. So I'll be really interested to see where that goes. People are starting to really redefine what the cement industry and what the construction industry knows. And it's an exciting time to be in the industry.
Definitely very exciting. And I mean, from someone who knows nothing about cement, it's exciting because you can see all the things that you wonder what direction would it take from those research and from these businesses or industries following those paths and using technology in that way. So I'm really curious to see what is that going to go. And I understand that change at this scale is never simple. What are the biggest barriers you see slowing down the adoption of low carbon and circular materials?
There's a number of things. It's kind of the usual suspect. It's going to be regulation. We're looking at the cement industry and standards and that, and they're very prescriptive. Yes, there's codes of practice available. There's a fantastic document called Flex 350. It's been produced by British Standards, so it's not quite a standard, but in a sense, it's a guidance note, and it's more of a performance-based document where you can say, well, actually, this doesn't comply with traditional cement and concrete standards, but it achieves everything it has to for durability, for performance. So there's a lot more of these types of documents and these types of mechanisms starting to creep into the industry. But it's fair to say there's still barriers around that because it's not a full standard. How do we de-risk that fully? If something goes wrong, is it the concrete producer that stands over it? The insurance companies don't know who stands over it. So while it's a step in the right direction, it's certainly not a silver bullet at the moment. Cost will inevitably come into it, but equally I'm a great believer in that. I think a lot of cost is added on to decarbonisation, I believe, to be profiteering in a lot of ways. And that's certainly not the case for every material, for every industry. But it stands to reason. If you're more heavily focused on waste materials and you're processing them in a less intensive way than conventional cement, but charging more for them just because of the carbon thing, it doesn't quite sit right with me. But in fairness, everything I've seen at the minute, cost is the first thing people ask about, but it's probably a secondary barrier because everything seems to be quite sensible at the moment and nobody's really going too heavily on the cost side of things. So for me, it'd be very much the regulatory side of things that's probably going to hold us up the most.
That is sad, but at the same time very realistic. So it's good that you give us that insight. Where do you see the most momentum right now?
To be fair, in the cement, there's a lot of momentum behind calcined clay. And the UK is one of the areas that maybe is lagging behind. There's so much interest and there's so many questions being asked about it. Where can we get it? How can we get it? How do we get this into our projects? And nobody's really went to market yet. And there's kind of a bit of a chicken and egg thing of who goes first. Is it the demand side say we must have this? Or is it somebody going to produce and bring it to the market and say, right, this is in the UK, this is available, come and buy it. So that's a really interesting piece, but there's definitely the wind is in the sails there. There's so much great work going on in that area, even at a much higher level. HS2 and companies aligned with them, another company called Expedition Engineering. There's individuals with those companies are almost single-handedly dragging the industry with them. And I was at an event later last year and the room was full of people that were interested in either learning more about calcining or giving their experiences of it. Yeah. So it's such an interesting part to be in, but it's relatively the norm in a lot of parts of the world, the likes of South America, where there's a lot of clay available. So it's not totally novel. It's just the UK is starting to catch up with it. But other areas, there's a little bit of momentum growing with biochar, which is a really interesting piece as well, where essentially you take organic material, where it's, say, waste trees or whatever it may be. You put it through a process called pyrolysis. So essentially you're trying to burn it, but in an absence of oxygen. So if you go back to school in your little fire triangle, no oxygen, no flame. So what that does, the heat, you're essentially getting rid of the contaminants, the nasties, and purifying whatever natural carbon is in that material. And it's almost like a synthetic charcoal that you would use in a barbecue, that type of material. So depending on the source material, it'll have different properties. It can be used as an ultra low carbon fuel. The other side of it is it can be added as a cement replacement. And some of the testing that I've done previously, we were able to achieve 10-20% addition. It improves the performance parameters in certain areas, but the biggest piece is that, for round numbers, 1 ton of biochar can absorb 3 tons of carbon. So if you can lock that away into the cement and lock it into a physical concrete structure, that can never go anywhere. So suddenly you're turning your concrete into a full-on carbon sink. So it's a bit more abstract, and a lot of the research is focused on the performance side of things, but definitely that carbon piece, it's just such a big area to look at. I'm really interested to see where that goes in the next few years.
We would like to keep an eye on that and follow that. So maybe in a couple of months or years, we can get you back to tell us all about it and explain it to us. Sustainability isn't just technical, it's human. How do you communicate complex, sometimes uncomfortable truths about environmental impact to stakeholders who are focused on performance, cost, and deadlines?
I guess my approach, it's easy saying it doesn't always work, but I'm a great believer in when we try to bring a novel material or something to the fore, we want to make things as familiar for the end user. So for an example, what I done my PhD research on, it was called geopolymer cement. So it was calcined clay, or if you could use GGBS or fly ash or whatever, and you added a caustic activator essentially, so like a sodium or potassium hydroxide and silicate, and essentially you're replicating the cement hydration reaction. It worked really well. It's a phenomenal product, but for a building site, he wasn't going to start to use this powder, then really carefully dose out a really caustic solution. So in terms of user friendliness, you're putting a barrier out there before anything, even performance-wise, anything could be demonstrated. So the first hurdle for me has always been, how do we make this as familiar for the end user? What you find is that starts to actually remove a lot of dollar barriers that come after it. It's certainly not indicative of the full industry, but there's still a traditional viewpoint where people still like to look for problems with a solution that's brought to them. And it's just about being kind of forearmed. If you've got as much information with you, you'll always get hard questions hit at you the first 5 or 10 minutes of any conversation with whatever level of stakeholder you're dealing with. If you can answer the questions, not tell lies about it, be factual and explain whatever they're asking, people tend to come along with you quite quickly if you can get over those initial fears that they have. So that's always been my approach. Try to be forearmed before going into conversations. Believe it, on the day-to-day practical side of the cement plant, you can't get anywhere unless you bring people along with you. You can't work in isolation. Yes, you do a lot in isolation in parts of the development, but you can't just keep it a secret and then come one day and say, right, we're going to do this today. You start to discuss with the likes of a control room operator, the guy who's actually running the site, well, what would this look like in practice? Because at the end of the day, instead of running the kiln at 1500, 1450 degrees to make clinker, we come up with a harebrained scheme of running the same kiln with the same operators at 800 degrees to make calcinex. We didn't just go into the room in the morning and say, right guys, this is what we're doing today. We spent weeks working with the guys who were going to be involved with it, explaining what's the benefits of doing it. Critically, what do we do if something goes wrong? But you never know 100% that it's all going to be okay, it's all going to work perfectly. So very much bringing people along with you in that journey. If you go and ask somebody, this is what we're thinking of doing, do you have any suggestions? And suddenly defensive guards come down. It's such a big thing that people can tend to forget about. When you're doing research, it's very easy to isolate yourself in terms of protecting the idea. But it never gets to reality if you protect it too closely.
Absolutely agree. I think that one of the most important things when you try to actually achieve some change from the academic perspective or the professional or industry based is the people you surround by, because they are the people who are going to either stop you from doing things or help you get the things done. When I talk about agents of change, people think, well, I am not an agent of change. I don't want to be an agent of change. But when you start saying or you start involving people, those defenses kind of lower down. It's like, yeah, well, actually, I am not so against change. And I do want a better planet. I want a better society. So I understand slightly what you mean there by involving people and engaging people. So looking ahead, what excites you most about the future of sustainable materials? I think we talk about this a bit, but is there any innovations that you're watching closely?
I think for me, the biochar and the whole kind of carbon piece, there's so much, what I can see coming, there's going to be so much movement in the carbon markets and how they fundamentally operate. Like at the moment in the UK, the carbon market is very much a emit and trade. It's a functional model, but it's by no means perfect. I think we're really quickly coming towards voluntary carbon credits and people actively wanting to get involved. And it's almost as a tangible demonstration of your sustainability. Or I still think a lot of big companies, more so than small companies, still live by the sustainability is something we put into our annual report.
Yeah.
And we tick these boxes to keep our investors happy. But I think that will start to shift. And that's why I think the voluntary carbon market will hopefully start to explode in the coming years. So that's one area that I'm really, really interested in terms of materials. Obviously, what I'm working on at the minute with the problematic waste materials as part of recycling or natural processing, there's so many opportunities there. So it's something that I'm obviously working day to day on. I'm really interested to see where this goes and really excited to hopefully start to bring solutions. It's a different approach. I'm used to kind of looking at the final product. It's now taking a step back and saying, well, actually, how do we build a piece of kit to take this from this? So it's such a fantastic challenge for me. I think it's not just the cement industry, but it's almost it's another industrial revolution we're going through. We maybe don't notice it, but it's got all the hallmarks of industrial revolution because we're now suddenly looking at reinventing how we do everything in terms of an industrial scale. So it's just an exciting time to be involved with that. And it's a great time for innovations because we're at a stage where people are much more receptive now to new innovations than they were 5 or 10 years ago.
Absolutely.
People are really paying attention to what's going on around them now, which is it's a big shift. I wouldn't call COVID the trigger for it, but from COVID, I found that people tend to kind of sit back more and just look around at what's happening. You see how quickly things can change and essentially societies can crumble
Yes.
with one flick of a switch. And I think that's translated in a much less dramatic way in the industry. But definitely I've noticed that shift in the last kind of 5-6 years.
Absolutely. And I agree. I have this big hope in humanity in terms of what we are considering as sustainability is not, as you said before, a tick in a box. I believe that more and more people are now avoiding the greenwashing, and we are actually more generally trying to find solutions that are sustainable as such. And we are having these discussions and conversations like we don't need to just say it's sustainable. We need to make it sustainable. We need to make it work for this generation and the many that are coming. So I'm very excited to see what's this new industrial revolution looks like. On a personal questions, what keeps you motivated when progress feels slow?
It's not always easy, but we're all the same.
Yeah.
And naturally you hit barriers. For me, it's something I've tried to work on. Usually I'll go headlong into something and focus on it, and I leave work or I leave whatever I'm doing, I'll go home and I'm still thinking about 11 o'clock at night. So actually one of the best things that I found is over the last kind of 12 months, so I guess since more so my second child arrived, I'm now finding myself going home in the evenings. I don't sit around and watch TV, it's not my thing. I'll always find something to do, but I'll always just park everything I'm working on for a few hours and even play with the kids and that type of thing. And while it doesn't help you when you've hit a roadblock in what you're working on, you subconsciously get a bit of a reset, because I know myself, I've been guilty of not taking time off, getting away from things. The biggest thing is taking that break, getting away from it and coming back with a clear head. Sitting listening to music, it's reading a book, it's going out for a walk, and then you have a random thought and you think, well, actually, that's the missing jigsaw piece. So yeah, probably getting away from it is what helps me most if motivation starts to dwindle or if things aren't quite working out the way I'd anticipate them to work out.
I agree. There's a quote, I don't know who that is from, that said, you cannot find the solution where you're sitting on the problem. So when you're ruminating the problem, sometimes it's not as easier to find a solution when you park it and have that balanced life and distract your brain from it. Has your work changed how you see the built world around you?
It has to. In a lot of ways, you suddenly become so much more aware of what goes into a building. When you know the numbers behind it, you know what it's taken to get that concrete block into that building, or even that steel stanchion. It's the cost of it, the actual work that goes into producing these materials. And one of the things that people underestimate about the cement industry, it's not like working in a shop, it's not like working in an office, whatever. It's a 24/7 industry. So the plants keep rumbling. They're so expensive to stop and restart again that they can't be stopped at 5 o'clock and started at 8 o'clock or 9 o'clock the next morning. They can't be stopped on a Friday evening. And what people don't see, like the bag of cement that lands at a building site, there's guys 24 hours a day, 365 days of the year in that cement plant, operating that plant. That includes Christmas Day. So it really changes kind of a level of mindset of understanding of really what does it take to build a building. I must admit, I'm not a fan of modern architecture. It's not my thing. And you look back at some of the fantastic buildings in Belfast, like very rarely do you stop in Belfast City Centre and look around.
Yeah.
And you look at some of the structures that have been there for 100, 150 years, and you just think, that's phenomenal.
Just one last question. What is an agent of change for you?
I'm uncomfortable about the thought of me being an agent of change, but I guess we've talked through it, and for me, it's facilitating conversations, it's facilitating innovations, it's not only coming up with ideas, it's trying to bring the ideas into practice, but I think putting it down to one person, I think that's where I'm uncomfortable with it, because I don't get the time to go and come up with ideas and to look at things or spend time in the lab to work on an idea. If the main part of my day job, I don't have a really good team around me to keep the wheels turning. So for me, an agent, it's more of a facilitating role. It's about allowing things to happen, and even whether it's coming up with ideas or realizing, well, actually, that's a good idea. If it's somebody else's, giving them the space to work on it.
Absolutely, yeah.
And it could be viewed as a selfish thing, but for me, it's the exact opposite.
It is, absolutely.
It's about giving people the space to do their job.
I completely agree. I think that some words that come to my head when I think of an agent of change is an instigator, someone who will try to get things done, and a catalyst. I think sometimes the main purpose of an agent of change is put people together, bring them together. It's like, I don't know anything about cement, but I believe in sustainability. I believe in a better world. I believe in the environment. I believe that we are in a very crucial time to make changes in society and the world. And the way to do that is things that we cannot change. Sometimes we cannot change the weather, but we can change the attitude we have towards it. So I think we cannot change many ways in terms of regulations or in terms of how society works or the economy, but we can change the way we perceive things. And I think that's very important. So that's one of the reasons why you are in this podcast today. And I wanted to just finally thank you for being in this conversation and for all the work you're doing. I have no doubt that you're inspiring young engineers and scientists out there and people who are working in the field and in the plants. I'm sure they look off you and they just want to follow your steps, and your family, of course. Your work reminds us that sustainability isn't only about lifestyle choices. It's about the systems beneath our feet, the materials in our walls, and the decisions made far upstream. And that change doesn't always come loudly. Sometimes it comes through persistence, precision, and purpose. To everyone listening, if this episode opened your eyes to the hidden impact of materials and constructions, share it. These conversations matter. You can connect with Allistair on LinkedIn and follow the work of CDE Group to learn more about the future of sustainable materials. Thank you for joining Conversations with Agents of Change. Until next time, keep asking better questions and keep building a better future, one choice at a time. This podcast is produced by the Change Impact Group.